So with Aaron, Aaron Reese is our first presenter. He is the forestry management supervisor with the city of Wilmington. He's been involved in professional tree care since 2007. He began his career with Davey Tree Expert Company, where he worked for 6 years as a tree trimmer and a foreman, before moving into his current position with Wilmington. He has earned a Bachelor of Science degree in landscape horticulture from Auburn University and has been an ISA certified arborist since 2010. He's a graduate of Davey Institute of Tree Science training program and is a professional member of ISA, and is also the North Carolina liaison for the Society of Municipal Arborists. Aaron's duties within the city of Wilmington include urban forestry management, commercial development plan review for tree preservation, public outreach and education, and enforcement of the city's tree protection standards. He is concerned with the lack of education about proper arboriculture practices among the general public and the private tree service companies in the Cape Fear area, and is quite passionate about increasing awareness within our field of tree care. Before I hand it over to him, I will, there's a couple of polls that he wanted to ask for people to participate. So just give me 1 second and I will put those up. And if you could all respond to the polls, then that would be great. They're not working. They're not showing up there. All right, I will work on that and I'll get the polls up to maybe towards at the end of presentation because it's not showing up here. So with that, Aaron, I will go ahead and stop sharing my presentation and you can take over from there.
Okay, just one moment. You getting my screen now, Leslie?
Yes, if you just want to go into slideshow mode, then you are good to go.
Okay. Okay, good morning, everyone. I will apologize in advance. Hopefully, I don't have much background noise here, but my office desk sits about 35 feet from a local 4-lane highway, so hopefully the traffic will be light this morning. We won't have much trouble with that. But my name is Aaron Reese. I am the Forestry Management Supervisor for the City of Wilmington. Obviously, if you're signed into this morning, you realize we're going to talk about trees and stormwater today. Between myself and Anna, I think we'll have a good presentation today, and there'll probably be a little bit of overlap between our presentations, but I don't believe that's a bad thing. So we'll go ahead and dive in here. A couple of you, I see we have a couple of people from Wilmington on this presentation today, so you may have heard most, if not all, of my presentation in some format or another. If so, I apologize. Hopefully I'll do better this time. So trees and stormwater. Trees and stormwater specifically in Wilmington, North Carolina. We recently completed a project with the Green Infrastructure Center with kind of a case study for trees and stormwater. I'll flip over to the slide here. Trees to Offset Stormwater was the name of the project. It was a project, you can kind of see the overview here if you'd like to read through that. This project took a look at two cities or counties in each of 6 states across the southeast. In North Carolina, Wilmington and Apex were the 2 cities that were chosen. This project kind of dove into all of our stormwater and urban forestry practices to see how we are currently using trees to affect stormwater runoff and pollution factors and stuff like that, but also to kind of help give us a roadmap going forward of where we can do a better job of using trees specifically to target stormwater, not just the typical benefits that we get from trees, but this project was specifically focused on stormwater. So it's kind of what we went forward with. The project was funded by the USDA Forest Service, was developed and implemented by the Green Infrastructure Center. I may reference them as GIC further on in the presentation, but that was the Green Infrastructure Center. They are a nonprofit. As I said, we had 6 states in the Southeast, 2 cities or counties in each state. I think they actually, their goal was cities, but I think they actually ended up with a couple of counties as well. We did get a lot of valuable information out of this program. We were able to see some things that maybe we had not thought about before. Kind of brought a lot of information to light. Was a very good snapshot of where we are now and where we can be. Gave us a lot of useful information that we could present to our city council to advocate for furthering our urban forestry program here in Wilmington. Quick snapshot of the findings from this project. The major drainage basins, the major watersheds that we have here in Wilmington is mainly the Cape Fear River and associating tributaries that they pretty much all directly drain to the Atlantic Ocean in some form or another. They either run off directly to the ocean on the east side, or to the west, they run into the Cape Fear River and then straight into the ocean downstream, downriver a little ways from Wilmington. Within the city limits, we have a little bit over 50 miles of streams, almost 200 acres of surface area of lakes, and our tree canopy, at the time of this study, which was canopy data was taken in late 2016, early 2017, so that was pre-Hurricane Florence, but our tree canopy was at 48%, which for Wilmington equates to a little over 14,000 acres of actual canopy coverage. Just some more quick facts there about the city. Almost 53 square miles total area within the city limits, 49.5 square miles in land, and almost 2 square miles in bodies of water. See the pie chart there is just another representation of that. So you take a look at this graphic real quick, these 4 images in this graphic. The difference kind of shows the difference in stormwater infiltration in different scenarios, going from a natural forest setting there in the top left. You go to the right, top right there, you have where you're starting to get some building occurring, so you've got a little bit of a mix there. Bottom left is starting to increase in urban, and then bottom right is a full-on urban setting where it's all concrete and tree wells with a tree stuck down in the middle of it. Hopefully you can see that, the numbers there, the transpiration rates and infiltration rates and runoff. Obviously, the more hardscape that you introduce into the environment, the more runoff that we get, the less water goes into the ground to replenish groundwater supplies. Because of the increase in runoff, urban trees become more and more important in filtering stormwater and filtering out a lot of the chemicals and compounds that run off of our streets and buildings. So filtering those out before they can make their way into our waterways and into our groundwater. Obviously, I think kind of goes without saying, a forest area, there's not much in the way of chemical runoff, man-made chemical runoff anyway. So, you don't have a ton of runoff, bad compounds and chemicals running into the groundwater, but as you go more urban, we're obviously going to have more of those chemicals that get into our groundwater, into our surface waters. So it's really not a good thing to have those, and I think Anna will probably touch on that a lot, probably in more depth than I will. That's her area of expertise, so I won't elaborate on that any further. But just to go along with this, 1 acre of fully forested land will typically release about 750 gallons of runoff in a average storm event. If you convert that 1 acre to completely paved parking lot, you're looking at 27,000 gallons. So there's a huge, huge difference. So obviously those are the extremes on both ends, fully forested versus fully paved. So there are, exceptions in the middle. A lot of things that we can do, pervious pavement options, directing runoff into, like rain gardens and stormwater retention areas and stuff like that that would help with this. But that's a lot of runoff when you're talking about a parking lot. And a 1 acre parking lot is not that big of a parking lot. It's pretty good size, but it's really not that big. So that's a lot of water that's just running off and not going into the ground. So through this study and some others, some information that was brought in to help with this study, been projects that have been done to measure the amount of water that is typically intercepted by a tree. You see here a typical straight tree's crown can intercept anywhere between 760 and 3,000 gallons of water per tree per year, obviously depending on species and age. And I believe that number is strictly crown intersection. I don't believe that number takes into effect all of the water that the tree actually takes up out of the ground after it starts to infiltrate. So I think that number would actually grow if you calculate all those factors in, but just the intersection of the canopy being over the hardscape or over the ground, that's a lot of water that's intercepted before it can make its way into typical city stormwater systems. Some of you may be familiar with the National Tree Benefits Calculator. This is a snapshot of the homepage here. I will attempt to get into this. Everyone see, Leslie, can you let me know if you can see this screen?
Yes, we can see it.
Okay, you can see the actual calculator?
Yes.
Okay, I will log into this here and just run through this real quick. If you're not familiar with this, treebenefits.com/calculator, you can see the web address up there. I'll go ahead and put in a zip code here for Wilmington. Get your zip code in, you can come over and pick a tree species. I'll drop down to the oaks here. Darlington oak is what we have the most of here in Wilmington. We'll go with the typical diameter, 20-inch diameter tree. We'll say this is a straight tree, so it'll be closest to the single-family residential area. We will calculate that, and we'll bring up this page. You can see it overall benefits, all the benefits together here, saying this 20-inch Darlington oak in a residential setting provides overall benefits of $107 every year. If you look down at the bottom of that screen there, if the tree grows, increases in size to 25 inches, it'll be up to $138 in annual benefits.
Hey, Aaron, it's not taking us to the Tree Benefit Calculator website. It's still just taking you to the screen. No, I just want to let you know.
Okay. Let me see. I may have to share that screen. Let me switch over. Okay. Can you see my browser window now?
Yes, I see your web browser. If you go over to the National Tree Benefits Calculator tab, you should be good.
Okay. Got it there?
Yes.
Okay. Let me try that again. Well, sorry about that. We'll start over. So this National Tree Benefits Calculator, this is a rough estimation tool of the benefits of trees, monetary benefit. You just go over here and put in your zip code. I'll put in the 28402 for Wilmington. We'll submit that. I'll bring up, go over here to the left side. I'll run through this again. I'll use the drop-down arrow to find species of tree. I'll go down to oak here. Go with Darlington oak. Again, that is one of our more common here in Wilmington. Do a 20-inch diameter tree, single-family residential, and just click on calculate. Hopefully everybody can see that. It's kind of an overall here. Again, the $107 a year annual benefits. You can see the increase at the bottom as the tree grows. Then you have tabs here along the top. You can kind of click through. You've got stormwater, actual property value, energy benefits, air quality, CO2. That's more information about the actual model. But I'll go ahead and flip over to stormwater since that's what we're talking about specifically today. And based on this calculator, and again, this is not an absolute perfect thing, but it is fairly accurate. 20-inch diameter Darlington oak in a residential setting, you know, you're looking at intercepting almost 4,700 gallons of water every year. That's stormwater that's intercepted and taken out of the stormwater system. So if you're adding trees this size, you have trees this size, it's like 4,700 gallons of water from one tree, one mature tree. And if you spread that out over the whole city, you're looking at a lot of water, millions of gallons of water that are intercepted by trees every year. So that's you can Google just tree benefits calculator if you can't find it, or like I said, I believe it's treebenefits.com. You can kind of see it there at the top of my browser. I will unshare. Let's see if I can. Get back to my presentation. Okay. Is that back to the presentation?
Yes.
Okay. Okay. So just wanted to run through that snapshot there. It's a useful tool. Take a look at that. There's a lot of people were involved. Casey Tree and Davy Tree were two of the main benefits, or two of the main contributors to that, developing that calculator. It's based on the iTree program, which is also another good program if you're not familiar with it. It's definitely something to look into, and I believe that the full iTree suite of software is free for anybody, if I'm not mistaken. So with that in mind, I said with a 20-inch Darlington oak, looking at about 4,700 gallons of water a year. That's one tree. So for the calculations that GIC came up with for the amount of canopy coverage in Wilmington, taking a look at the average high volume rainfall, basically a 10-year storm event, over 24 hours in the city limits, based on our canopy coverage, we're looking at a water interception by trees of 240 million gallons, which that's a big number. Kind of put it in perspective a little bit. 363 Olympic-sized swimming pools completely full. So that is a lot of water. A little bit more in perspective, that same amount of water goes over Niagara Falls every 5.7 minutes. So if you've ever been up to the falls and can kind of get a feel for what that is at full flow, give you a little bit of an idea of the amount of water. That's not the amount of water that falls on Wilmington in that storm event. That's the amount of water that is taken up by the trees in Wilmington during that storm event. So you can imagine the actual rainfall is quite a bit more than that. As part of this project, GIC developed a model for us for stormwater reduction for all of our different watersheds throughout the city. Anna can probably correct me on this if I'm wrong, but I think we have 16 or 17 different watersheds within the city limits of Wilmington. And just using that reduction model that they came up with, you know, the potential for increasing water capture, if we had a very aggressive canopy goal, increasing canopy in all of those watersheds significantly, we could, you know, potentially look at adding another 130,000 to 1.7 million extra gallons of water captured by trees in those watersheds. The graphic here is just a snapshot of that calculator for one specific watershed within the city, the Bernards Creek watershed. You can kind of see some of the numbers. I know there's a lot of numbers there. I'll be honest, they don't all make sense to me because I'm not a stormwater person. But if you look down at the bottom little green box at the bottom right-hand side of that graphic, the increase that they had in this particular instance in this model would increase water capture about 3.8 million gallons, which is pretty significant. And I'll clarify that 130,000 to 1.73 million gallons that I have in that first sentence is per watershed. That's not an overall. That is the range per watershed that we could potentially see. I believe I sent Leslie the download to the final document that was developed for us. We'll make that available to everyone. A lot, kind of the overall findings for this project. If anyone would like more information on the actual numbers, if you'd like to take a look at these models, stormwater reduction models that GIC laid out for us, if you would like to contact me directly, I can make those available to you. I can send you the full package if you would like to see it. It's all public information, and I can have it all in a file. I can send it to you if you would like to see it. So with this, just to kind of wrap up, that's the end of my presentation there, but just to wrap up, all of the work that was done as part of this project was able to give us a very good idea of the direction that we can take in using trees specifically to capture even more stormwater, and how critical preserving the urban forest in Wilmington is to stormwater. And being a coastal community, we have a lot of water. We have a lot of runoff, have a lot of sensitive areas around our community that can be heavily impacted by stormwater runoff. So the more that we can do to stop that water from entering, that stormwater from entering our tributaries, the better off the community will be, and generally the state as a whole. So we have learned a lot from this study. I know for some of us that were not necessarily directly involved in stormwater every day, like myself, I work with trees. I understand enough about stormwater to be dangerous. And I knew that trees use a lot of water, but it really opened my eyes to see how much they actually do capture across an entire community. So it was definitely an eye-opening study, gave us a good starting point for some good initiatives that I think will be implemented at some point in the future. Some that we're currently working on, some that are kind of just a thought right now, but may be implemented later. So that is the end of my presentation. You can see my contact information there. Feel free to email or give me a call. I'll be happy to answer any questions that you have. With that, I will stop sharing and turn it back over to Leslie.
Yes, thank you, Aaron. And I will make, at the end of Anna's presentation here, I will make the handouts that Aaron and Anna are referring to available for you guys to transfer. Anna, if you want to go ahead and share your screen, we'll get started on your part of the presentation. So I'll make sure that the file transfer is available to everybody, and you can download those documents at the end of the presentation. While Anna gets set up. So Anna Ray Gingrich is currently works as the Watershed Coordinator for the City of Wilmington. She manages the Heal Our Waterways program, which promotes stormwater solutions to property owners and provides funding to help eligible residents implement LID practices. She graduated with a Master's of Science in Coastal and Ocean Policy from the University of North Carolina, Wilmington, and has enjoyed giving back to the ecosystem she fell in love with during her studies. And with that, Anna, you are good to go.
Thanks, Leslie. Hear me all right?
Yes, you are perfect.
Awesome, thank you. Thank you so much for that introduction and for inviting me here today. I am sorry that we're not able to see each other in person, so I hope this picture fills in well. I love water. I love it in all of its states, even solids, even though we don't really get it that frequently in our area. But I took that interest and ran with it. My background's in marine biology and coastal and ocean policy. And I really enjoyed the challenge of kind of digesting scientific concepts to a point that policymakers can use that information and the public can understand it. And it's been really nice to be able to use those skills in my current position as the watershed coordinator for the city of Wilmington. And like Aaron was kind of alluding to earlier, I am really concentrated on stormwater runoff. So I'm coming in from kind of a different perspective. So I'm trying to keep it pretty broad. I apologize if you already know some of these concepts, but I hope this will give you a good base to stand on for what we're talking about when we're trying to promote improvements to tree canopies for the benefit of stormwater runoff. So the slogan, everything goes somewhere, I saw it on a poster and fell in love with it because I thought, what a perfect way to talk about stormwater runoff. Because when it rains, it's got to go somewhere. Everything does go somewhere. And when I'm talking about stormwater runoff, it's when it rains, that rain hits hard surfaces, which we call impervious surfaces, because the water cannot permeate through it and reach the groundwater table. And it runs over those surfaces that are like rooftops, sidewalks, roadways, parking lots, and it picks up anything that wants to go along for the ride. So things like pet waste, fertilizers, motor oil, litter is a very visible one. That all goes untreated directly to our local waterways because the water is moving off of those roadways. So in New Hanover County, we have 3 water systems. We have the drinking water treatment system and the wastewater treatment system, and both of those systems have a facility that actually cleans the water. So I use this visual to show that stormwater runoff does not have one of those facilities to clean the water, and that's why we end up with unhappy fish at the end of those systems. And why does talking about stormwater runoff matter? Well, it affects us in 2 big areas, the first of which is flooding. Probably 95% of the phone calls we get on a daily basis are related to flooding concerns in local neighborhoods. Here in Wilmington, we're not exactly a very mountainous region, so we're very flat and we're very easy to flood, and especially with more storms and more rain in each storm. It's been an interesting challenge to try to adapt to the changing conditions and continue to move that water so that we don't have these flooding concerns. And then on the other side, which is more of my focus area, is stormwater pollution. So those things that I was talking about earlier that stormwater picks up and carries to local waterways, that's known as non-point source pollution, and it lives up to its name. It's very difficult for us to track what those sources are. So really it's everyone's responsibility to try to prevent it from entering the environment in the first place. because it's also very difficult to clean up once it's in our waterways. So one hand, it clogs storm drains. If you have a lot of yard debris, leaf litter, litter in general in your storm drain systems, it takes time and it takes money for us to clean those things up. So it's to our advantage to try to prevent it from entering those systems in the first place. Some pollutants can be harmful to human health. If there's a lot of bacteria in a waterway and people are swimming in it, they can get infections, they can get gastrointestinal illnesses. In our area, we have shellfish closures because those waters have too much bacteria in them. So it's actually unsafe to harvest those shellfish and consume them. And it's also harmful to the wildlife in our waterways. You see the pictures of turtles that have straws in their nostrils and plastic bags in their mouths, and those are kind of the poster children. Obviously, there are a lot more. There are several more examples of what else could happen to wildlife, but those are the things that really motivate people, and it's cool to see actions being implemented when they have these very visible examples of how wildlife can be harmed. So those are just some of the broad topics that I deal with a lot with non-point source pollution. And I think these conversations with stormwater runoff being a concern has kind of increased in recent years, but the problem hasn't happened overnight. Changes to the landscape have been happening for a pretty long time. As you can see, these are some aerial images from our Bradley Creek watershed. And from 1981 to 2010, and I'm sure even from 2010 to today, you can see that a lot of that green space, a lot of those forested areas have been changed to subdivisions, businesses, roads for people to get from their subdivisions to the businesses, schools. We're adding a lot of those impervious surfaces. So, the water is not able to soak into the ground like it used to be able to. So instead, we're generating more stormwater runoff in these areas, which is also, I am kind of repeating this graphic from what Aaron had in his presentation earlier, but I think it shows it really well. So rather than having trees and soil to soak that water in and actually use that stormwater, so very little of it becomes stormwater runoff, we're adding in more impervious surfaces. So that water doesn't have a place to go. So it turns into stormwater runoff. So I don't want to stay on this too long since you've already seen it, but I think it's a really good visual for the concepts that we're talking about. And as you have more stormwater runoff, you're also going to have more pollution running towards your waterways. This is a graphic from a study a UNCW professor did, and he looked at the relationship between the percentage of impervious surface coverage in a watershed versus the quality of the water samples that he was taking from those creeks. And he found that the creeks that had greater impervious surface coverage also had higher counts of fecal coliform bacteria in those samples. So we can see the relationship here. As we're getting more stormwater runoff, we're getting more flooding, we're getting more pollution to our waterways. So what can we do to try to manage that stormwater runoff? And one of those ways is green infrastructure. And that's what I try to promote to people through the Heal Our Waterways program. And green infrastructure is really trying to go from those highly urbanized property statistics and try to change it to function a little more like it did when it was a natural area. So both these pictures I took from New York City, and you can see that it's a pretty urbanized area, lots of rooftops, lots of roadways, lots of buildings, that they have a lot of stormwater. So on the right side, it's really cool that in some parts of New York City, they're trying to incorporate more of that green infrastructure by incorporating trees, incorporating garden areas, and they also add art to, this is the High Line here, and it turns into a feature that people actually go to visit and see nature in action in a cityscape. So I think it's a pretty cool concept. Now, the Clean Water Act has a bit of a mouthful of a definition of what green infrastructure is, but it's the range of measures that use plant or soil systems, permeable pavement or other permeable surfaces or substrates, stormwater harvest and reuse, or landscaping to store, infiltrate, or evapotranspirate stormwater and reduce stormwater flows to sewer systems or to surface waters. That's a mouthful, but it's pretty easy to see it in action. So here I have some examples of stormwater solutions that I try to promote to property owners. They can range from something as simple as having a rain barrel at your home to capture roof runoff and use to water your garden bed, to something that's a little more urbanized, so using pervious pavement or pervious pavers to capture and allow that water to infiltrate into the ground under the parking lot. So it really matters what your site looks like, what type of stormwater solution you can implement, or what type of green infrastructure you can use. And I don't know a better example of green infrastructure than trees, not just because a lot of them have green leaves, but because they fit so well into that definition of what green infrastructure is. And this image is actually from that website that Erin was showing earlier, and I think it does a really great job of showing the ways that trees can help manage and treat stormwater runoff. So if you talk to my more engineering-minded peers, the tree canopy is really what they focus on. That's what's going to provide the biggest benefit for stormwater management, because the tree canopy can actually capture and allow the water to evaporate back into the atmosphere so it doesn't even reach the ground in the first place and doesn't become runoff. But I like to look at the tree as a whole system, because there is some water that's still going to come through the canopy, but also people could direct water towards the trees. In some of the examples of stormwater control measures that we use. So, the roots also play a good role in soaking in some of that moisture that's in the soil so that the soil has a greater capacity to absorb more of that stormwater and less of it becomes runoff. Some trees can even take up pollutants, certain types of pollutants, and transform it. And so not only are you reducing the amount of stormwater runoff that's being generated, but you're also treating some of that runoff that is reaching. And I don't think I need to justify to you guys why to plant more trees, but here are some additional benefits in addition to the stormwater runoff benefits. They provide food, they provide shelter for wildlife, they are pretty aesthetically, they make people happier, they give you better energy bills if you plant them in the right places around your house. They clean the air we breathe. It's pretty amazing everything that a tree can do, and we should be planting more of them. So how do we actually incorporate them into stormwater management? So I'm going to give the same advice that I give for putting in any type of stormwater control measure. You really need to look at the site that you're working with and think of it with stormwater in mind. So it's important to look at what types of soils that you have and how well drained those soils are. So what I recommend people to do is to do a percolation test. So you dig a hole about 1 foot to 2 feet deep and fill it with water. Start your timer. If your water is gone within 2 hours or within 24 hours, 2 hours would be amazing. Within 24 hours, you have very well-drained soils. If it takes longer than that, you probably have decent drainage, but if it's longer than 72 hours and you still have standing water, you're going to want to look at tree species that can withstand standing water. And if you're going to combine it with stormwater control measures, you're going to want something that's more along a wetland type of project. So, that's really important. That should be the first step that you do. You also want to look at the space that you have. How many trees could you put in? How big could the trees be? And then you want to look at how the runoff is going to flow in that space. So, if you have a lot of impervious surfaces around you, you're probably going to get more runoff in your site, especially if it's a low spot. And you also want to consider how quickly that stormwater will be entering that site, because we've had a couple of instances where we planted some younger trees and plants, and there was a area that the water would rush through it, and it drowned the plants that were there and washed some of them away. So if you have those types of flows going through your site, you're probably going to want to make sure you have larger plants and larger trees that can establish pretty quickly. So what I recommend people to do is to do the stormwater yoga flow. I'm kind of doing an example of it to this group that we're about to plant a rain garden. You want to look at where your source of stormwater is, where it's going to flow on your site, what areas are going to probably be more dry and more wet. And it's really helpful to look at it when it's actually raining too, so you can see it all in action. But get a good feel for your site and just kind of go with the flow. For engineering considerations, when you actually get into the design of your project, especially if you're incorporating trees, you want to think about the goals. So where is the source of the runoff that's coming into my design, and how can I tie it into my project? Am I looking at water quality, or am I looking at water quantity? Am I only trying to reduce or mitigate the additional impervious surface that I added to a property, or am I trying to go above and beyond and really provide a benefit for water quality? With these projects, or with these designs, most of them are designed for a certain size of storm. So typically what we do is 1.5 inches, but to overwhelm, sorry, I just got pop-ups here. You don't want to overwhelm your system and drown the trees that you have in your design, but you also want to make sure that trees still have access to water. So, you want to make sure that you have some place for that water to go, because everything goes somewhere. You also want to, make sure your tree is going to survive. Does it have the space that it needs? Will the roots have space to grow? You don't want it to be competing with sidewalks. You don't want it to be competing with roadways. So some things that I've seen really creative people do is incorporate several stormwater control measures into one. So they put pervious pavement in places so that the water can soak into a space that is dedicated underneath it just for tree roots. So, talk to your stormwater engineering folks, see what you can do to combine forces and really make a project that will benefit both the tree and stormwater. So how are we implementing some of these practices locally? Aaron kind of alluded to it earlier with his presentation. We're doing what we can to start planning for how we can improve tree canopy in priority watersheds. So the program that I manage is basically the implementation of this voluntary watershed restoration plan that the city has adopted, because we do have some of those shellfish closures. So we're trying to do what we can to reduce this amount of stormwater that's transporting that bacteria to those waterways. So it's really great because it allows us to do grant projects and build partnerships. But what is most helpful is that it establishes clear goals and priority areas for us to work in. So we combined the data that the GIC grant provided to us with their potential planting areas, and kind of overlaid it with where my priority areas look like right now. So, we have Bradley Creek and Helix Creek, and my program actually has funding to implement stormwater control measures on city properties within those two creeks. So went ahead and did it. So we started doing plantings. It's been great collaborating with Aaron to figure out when I tell him, here's the site that I'm working with, here are the stormwater considerations. This fire station has a really soggy area that backs up every time it rains. What would be something good that we could put in there? And then he's able to give me ideas for tree species to plant and helps us plant them. So, it's really important for whichever agency you're working with to talk with your forestry and stormwater folks so you get both of those perspectives so you can collaborate on projects like this. And then it's also really important when you're doing these projects to make sure you track them, keep tabs on where they're going in so that you can measure the outcomes that you're working towards. So for me, I have two tools that I use, one of which is from the GIC. They provided a spreadsheet that looks at how we can quantify the amount of stormwater we're reducing, looking at the overall canopy within each watershed. So I can go in there and I can increase canopy or decrease canopy and see how that influences what the volume looks like within each watershed. I also have the tool on the right, which can look down to the individual tree level as long as I have the average tree canopy diameter. And this tool was designed with the watershed restoration plan. And so with that, I just need number of trees and the average canopy tree diameter is, and I'm able to estimate how much volume reduction that tree is providing. So how much stormwater is reducing from entering our waterways. Now, both of these focus solely on tree canopy, kind of what I was talking about earlier. It is where you're going to get your biggest benefit, but for me, I also like to look on that National Tree Benefit Calculator that Aaron featured to show, okay, it's more than just canopy. There's some benefits that we can get from the entire tree as a system. And I use that more for my own education purposes. So it's really important to track everything, map everything. Basically, if there's anyone you can share data with, do it. The more data, the better, because you want to keep track of where your trees are going in to make sure that they're still growing, that they can still succeed, and so that you can get a really good idea for where those areas are that you're getting those stormwater management benefits. And with that, for us reporting, we report on how much runoff we're reducing, so how much volume reduction we're achieving with each project. Because the greater the volume reduction is, that means there's less stormwater that's able to cause flooding problems or to transport pollutants to local waterways. So if there's one takeaway from this slide, it's that the larger the tree, the larger the volume reduction. If you're using only trees for stormwater management and you're not combining it with any other stormwater control measures, you really want to go for those larger trees that have the large canopy and large root system so that you're getting the maximum volume reduction that you can for what's applicable to that site. So with that, some final takeaways I have are right tree, right place. I think you guys all already know that, but just to reiterate, add in there some stormwater management considerations. So, look at where the runoff is going, what's going to be a wet zone, what's going to be a drier zone, so that you can pick the right tree for that site. Track your trees so that you can report on the successes that you're achieving and get a good idea of how you're benefiting stormwater or how you're benefiting local water quality by keeping track of those volume reductions. And I think I tried a little too hard on this last acronym. I promise I'm not blowing a raspberry at you guys, but the bigger the tree, the bigger the benefit. So if you're looking to plant a tree in a space only for stormwater management without anything else attached to it. Those larger trees are really going to give us those big volume reduction numbers. You see really nice, big, beautiful benefit, especially with all of the other things that trees can provide as well. So that's really my presentation. I have some links here at the end that you're welcome to look through that I use to help build this. And with that, I will back to Leslie.
All right, great. Thank you, Anna. So if you can unshare, I'll get back to my screen. What we'll do now is do the question answer period. So if anybody has questions, if you could go ahead and just type them into the chat dialog box. You can send them to everyone, or you can send them directly to me, Leslie Moorman, and we'll read through and give Anna and Aaron a chance to respond. It's a great opportunity to get some insight into how a municipality has started integrating trees into their stormwater management. You can ask some specifics on any holdups or success stories there. And while people are typing out their questions, sorry, I wanted to go ahead and see if I'm going to go ahead and try to put up the sorry, I'm going to get